All right, this is Coach Williams, and we're going to go over 5.2 notes today. Today's section is going to be solving systems of linear equations by substitution. Yesterday we did solving by graphing. We graphed the linear equations, found their intersection point, and then we checked that coordinate to make sure that it was a solution. Today we're going to solve by substitution. Substitution is actually maybe a little bit easier, especially once you get the hang of it. It can save some time trying to create a graph and trying to find the slopes and such. And the steps that we're going to use here, I'll go over them. They're going to maybe sound like gibberish at first, but then once we get into this, it'll make a lot more sense. But the steps we'll use is that we're going to solve one of the equations for one variable. And this is going to be kind of a cool thing because this is going to give you the freedom to pick whichever variable that you would like to pick. Up to this point, we've been drilled and hammered that we've got to, solve for y, get everything in terms of y so you can get y equals mx plus b, y equals mx plus b. Well, at this point, you can pick whichever variable you would like to solve for. You can solve for x, you can solve for y. A lot of these equations are already going to be solved for us in terms of one of the variables, so it's going to help us out when we get started here. But we're going to have to solve for one of the equations, for one of the variables. The next step we're going to do is we're going to substitute the expression that we found in step 1. So when we solve for x or y, whatever we find is equal to x or y, we take the whole thing and we substitute it into the other equation and then solve for the other variable. And then once we find that variable's value, we'll substitute the value from step 2 into one of the original equations and solve. Again, maybe a lot to take in if you haven't seen this before, but it'll make a lot more sense as we move along. Let's jump right into the extra practice. And just so you know, there are about 18 or so problems, 18, 19 problems on this extra practice. We will not work all of them. In fact, we will work maybe about half of those problems. I will try to give you a pretty good grasp of types of problems, but they're all the same thing. We're doing substitution on all these, so we're not going to change our methods as we move along. This is going to be the same thing on all the problems, so it's a lot of repetition. That's the reason why we shouldn't have to work all 18, 19 problems. We will work the word problem at the end because I feel like we need to make sure we understand how to pull the equations out of the word problem. All right, so on the first equation or system of equations, you're going to see that they've already solved for y in one of the equations. Y equals 5 plus x. And so since y equals 5 plus x, we can go ahead and just plug in this expression where we see a y in the first equation. So let's do that. 2x plus 2 times, and I'm going to open parentheses here because I have an expression that I'm going to put in there instead of y. What does y equal? Well, y equals 5 plus x. So I'm going to put 5 plus x right there. And that's going to be equal to 10. So if you notice, once we substituted in the y values expression into this equation, now all we have are x variables. And as long as we have one variable, we can solve for that variable, find its value. And then once we find the value, we can plug it into the other one and get its value. We'll show you how to do that. So now we're just going to solve for x. What's x equal now that we've substituted in this y value? Well, we got 2x, and then we're going to have to do a little distribution here. So we're going to distribute the 2 into this parentheses. 2 times the 5 is 10. 2 times the x is positive 2x, and this is still going to equal 10. Now, we've talked about this before in class, but anytime you have the same value on both sides of the equal sign, it just cancels. And you can see that happening. If we were to minus 10 from this side, I'd have to minus 10 from this side, and it just makes them both go away. So anytime you see the same value on both sides, you can cancel it. Make sure it's the same value with the same sign. And then we're going to be left with 2x plus 2x, which is 4x, and that's just going to equal 0. And this makes it easy because we're going to divide by 4. Divide by 4, x is going to equal 0. Now that I have a value for x, I can take x and I can plug that in to either equation. I can go either one. Doesn't really matter to me. Now one's going to be a little easier than the other, but I can plug it into either equation and find out what the y value is. If you'll take the equation that already has y by itself, then it makes it pretty much a straightforward answer. You're going to put y equals 5 plus the x value we found, and then you just combine like terms and you know what the value is. So let's pick the bottom equation. The bottom equation already has y by itself, so y is going to equal 5 plus, what is the x value? 0. So we're going to plug 0 in right there. So simply y equals 5. So I have my two values, y, or my x and y values, and so the solution to this system is going to be 0, 5. We know it works in the bottom one, but if I were to plug this into the top equation just to check it, because we're supposed to check our solution here, 2 times 0 is 0, plus 2 times 5 is 10, and 10 equals 10, so it checks out on the top equation as well. So that is my ordered pair and the solution to this system of equations. Does it start to make a little bit more sense here? All right, let's work number 2. Number 2, again, we have a variable that's already by itself. It's already been solved for, and so we're going to take this whole expression, and where we see an x in the first equation, we're going to plug it in. So we're going to have 2 times x. Well, x is now negative 2y minus 1. And then we're going to have to put our minus y on the end, and then it equals 3. Okay, so now we've got to do a little work to clean it up. We're going to have to distribute my 2 into the parentheses. So we're going to have negative 4y when I multiply 2 times the negative 2y. Negative 2 when I multiply 2 times the negative 1. Minus 2 still equals 3. Alright, and then we're going to combine like terms and take our 2 across to the other side. Okay, so we're going to combine this term and this term together, and we're going to move this term over here. Now, we've talked about just moving terms and not having to go through all the steps of adding, subtracting, etc. When I move this negative 2 to this side, it just changes the sign. So I'm just going to take that one away, add it to the other side. If you wanted to see the step, we're adding 2, adding 2. It's the same thing. So this goes away. Negative 4y and a negative y are going to combine to equal a negative 5y. 3 plus 2 is going to combine to equal a positive 5. And so when I take and isolate the y variable by dividing by negative 5, then y is going to equal a negative 1. And that's pretty easy, because then I can take that negative 1, plug it into either equation. I'm going to plug it into the bottom one again because x is already isolated, and I just have to find out what the y value is, and then it's going to tell me what x equals. So I'm going to plug that in. I'm going to have x equal to negative 2 times y, which is a negative 1, minus 1. Negative 2 times a negative 1 is a positive 2, minus 1, and 2 minus 1 is simply 1. So now I have both values, my x and my y values. So I have 1, comma, negative 1. That's my ordered pair for this solution of the system of linear equations. So that is my answer. Okay, on to number 3. Now this one's pretty simple. Once we find one variable, we found the other one because x equals y. X equals y. So when we find one of them, we can just know the other one is the same thing. So let's go look at how we're going to do this right here. We can either plug in x for y, or we can plug y in for x. It doesn't matter. Let's plug y in for x. Okay, so we're going to take this value right here, we're going to plug it into that. Where we see an x, we're just going to put a y. So now y minus 3y equals negative 1. Okay? Y minus 3y equals negative 1. So then I'm going to have y minus 3y is going to be a negative 2y. And negative 2y is going to still equal negative 1. I'm going to divide by negative 2, divide by negative 2. That becomes a 1, so it just, in essence, goes away. Y is going to equal a positive 1/2. Well, if y is 1/2, what is x? 1/2, because y equals x, or x equals y. So we can take this right here, we could plug it into that, and immediately we're going to have x equals 1/2 as well. Now I know that works on that bottom equation because they just equal each other, but what about the top equation? What about the top equation? Let's check that top equation and make sure, because we got fractions here, let's make sure that we're correct. If I have 1/2 minus 3 times 1/2, right? Or 3 and 1/2, it's the same thing, equal to negative 1. Is that correct? Is 1/2 minus 3 1/2 correct? Well, yeah, it is actually, because I've got a positive 1/2 here. I'm going to subtract 3 and a negative 1/2, right? So won't the 1/2s just go away? Well, actually, 1/2s will go away, but we've got 3/2 actually. We've got negative 3/2. Let me rewrite this so it makes better sense. We've got 3/2, which is actually 1 and 1/2. It's actually positive. So we've got minus 3/2. So we've got 1/2 minus a negative, or minus 1 and 1/2, which equals negative 1. Let's rewrite it like that. That's the easier way to rewrite it. So we've got 1/2 minus 1 and 1/2, because 3/2 is the same thing as 1 and 1/2. So now I can do what I was trying to do before. Positive 1/2 and negative 1 and 1/2 just means that the 1/2s will go away. If I take 1/2 away from 1 and 1/2, I get a negative 1. So those go away, and that does equal negative 1, so it checks out. So the answer is 1/2, 1/2. That is my solution to this system of linear equations. Okay? All right, so that's 1 through 3. 4 through 6 are going to be much of the same thing. You'll notice that, again, they're going to isolate a variable for us. We don't have to do quite as much work. I'm going to skip working number 4, and let's do number 5, just for sake of time here. I want to get to a couple other examples that show us where we're going to have to do a little more work to isolate some variables. So let's work on number 5. Number 5, we're going to have x already isolated right there. We're going to plug that in to the x location in the first equation. So we're going to have 2 times, what is x? It's 3y plus 5. Then we've got to add y to that, and then we're going to equal that to 3. So we're going to have to solve for y now. We'll multiply this in, and we're going to have 6y, I'm going to multiply this together, plus 2 times 5, which is 10, plus y equals 3. And then I'll combine my y terms, and I'll move the 10 to the other side, or I'll subtract 10 from both sides. When I combine y's, I'm going to get 7y. Put those two together, I get 7y. When I minus 10 and minus 10, I'm going to equal a negative 7. So then when I divide by 7 and divide by 7, y is going to equal a negative 1. Now when y equals a negative 1, I'm going to take that value, plug it back into the x equals equation, and it should give me the x value as well. X is going to equal 3 times a negative 1 plus 5. 3 times negative 1 is a negative 3, and negative 3 plus 5 is a positive 2. So x should equal 2. So my solution to this system of equations should be 2, negative 1. to negative 1. All right. So we want to make sure that we are checking these as well as we move along. We know it works in the bottom one. If we plug a 2 into this top one, that's going to be 2 times 2, which is 4. And 4 minus 1, because y is a negative 1. 4 minus 1 is 3, and 3 equals 3, so that does check out. We know it works in the bottom one because that's how we got the last value. So that one does work. You know, we skipped number 4, but let me just make mention of this too. We've got x minus 2 times y. If we plug in this x plus 1 in for y, you need to remember to take your minus 2 when you're distributing into that. It's a negative 2 times x and a negative 2 times 1. And we'll probably see some more examples of that. Just make sure you remember to carry your negative or your sign with the 2 when you distribute into your equation on number 4. All right, let's go ahead and flip the page and go to number 7. On number 7, they give us options, and that's not a bad thing. What's going to end up happening in many cases is you may have chose to solve for a different variable than maybe I did, and maybe a different variable than your neighbor does whenever you're working these in pairs when you're working on the practice together. You may solve for x, and they may have solved for y first. In this case, they've actually got us a decision to make here because they give us y in 2 different expressions. We have 2x plus 8, and we have negative 2x. So we have to pick which one we want to use to plug into the other one. I'm going to go with the easier route. I'm going to go with less terms. So I'm going to take this, and I'm going to plug that in to the big equation, or the bigger equation with more terms, we'll say. So let's do that. I'm going to have negative 2x instead of y. I'm going to have negative 2x equals 2x plus 8. Then I'm going to need to move my x terms together and keep my integers on one side. So I'm going to minus 2x and minus 2x, or move this over there, which just changes the sign. So then what that does for us is that goes away. This becomes negative 4x equal to 8. And when we want to solve for x, we're going to divide by negative 4. Divide by negative 4. And x is going to equal a negative 2 when we have 8 divided by a negative 4. And then I can, at this point, because they're both in terms of y, I can plug in this negative 2 into either equation and immediately find out my answer for the value of y. So I can plug this into either one. I'm going to use the bottom one because it gives me, again, less terms to have to deal with. So let's plug in negative 2 into the bottom equation. Y is going to equal negative 2 times a negative 2. I'm going to pull that x value right into this spot where the x is. I'm substituting this value back in. So then negative 2 times negative 2 is just a positive 4. So now I have both of my values, and my x value is negative 2, y value is 4. That is the solution to this system of equations. Alright, number 8 has some fractions. And if it helps you when we're dealing with fractions to use your calculator and put it in decimal form, then so be it. That's fine. You can do that. You're going to come up with the same answer. And it's not difficult to work with fractions as long as you know the methods and understand how to deal with the fractions in adding, subtracting, multiplying, dividing, etc. Which by now, at this point, we should. So I'm going to pick, again, they give us an option to pick either one of these. I don't know which one you would have picked, but I'm just going to go with the 1/4. I'm going to use y equals 1/4 x plus 3, and I'm going to plug that into the top one. So I'm going to end up with 1/4 x plus 3 on the left, and on the right is the rest of the equation. It's supposed to equal 3/4 x plus 1. And this is an easy fraction to deal with. You're just dealing with quarters, basically. You've got 1/4 and you've got 3/4 over here. So maybe that'll help as we move along through this problem. I need to get the 3 on the right and the 3/4 x on the left, if that's the way you so choose to group them together, get our x's on the left and integers on the right. So I need to subtract 3 and subtract 3 to get that on that side. And then I need to take 3/4 and move it over here. Well, this is a positive, so I've got a minus 3/4 x and minus 3/4 x. Alright, and when I do that, I've got a positive quarter and 3 negative quarters, so it leaves me with 2 negative quarters, right? Because it cancels out one of the negative quarters, the positive quarter does. So I'm going to leave it in fraction form, and just like that, 2 negative quarters equals, and again, that went away, that whole thing went away. What's 1 minus 3? It's a negative 2. And again, we can look at the process rather quickly here, which gives us our common little saying about dividing by fractions. We don't divide by fractions, we multiply by the reciprocal. And it's pretty simple to see why we do that. We're dividing by 4 here, so I need to multiply by 4 to get rid of it, right? To undo division, I multiply. So if I multiply by 4, then I'm going to do that. If I've got a negative 2 that's been multiplied, I need to divide by that negative 2. So if you'll notice, I've just created a reciprocal when I divide by 4, or I multiply by 4 and divide by 2. So I'm going to have to do that to both sides. So this will cancel, and if you'll notice on this side, my negative 2's will cancel, and I'm left with 4 over 1. So x just equals 4. Alright, I can take that 4 value, plug it back into either one of them. I'm just going to plug it into the bottom one, and we should be able to get our answer fairly quickly. Y is going to equal 1/4 times 4, and I'm going to put it over 1 so it kind of makes it easier to see, but that 4 is the same thing as 4 over 1. 1/4 times 4 over 1. Alright, then we're going to add to that a positive 3. Well, 4 times 1/4, the 4's are just going to end up becoming a 1, because 4 over 4 is 1. So this whole thing becomes a 1, and 1 plus 3 is 4. So both y and x values end up being 4. Our solution is 4, 4 to this system of linear equations. And we could plug those back in and check those as well. Alright, let's move on to number 10. I'm going to skip number 9. I think number 9 is pretty easy. They already gave us the value for y. So I just plug 4 into the top equation. I can find x, and then we're in good shape. Correct? So they gave us a little early Christmas present on number 9 there. Alright, let's look at number 10. Number 10 is not set up as easy as the rest of them have been. If you'll notice on number 10, we have no variable isolated. So we're going to have to isolate a variable. And this again is going to be where you and I and you and your neighbor and you and the person in the other algebra class may differ on how your answers work or your problem is worked out. You should arrive at the same answer any direction you choose or any path you choose to take here. You should arrive at the same answer as everybody else. But you have the freedom to use whatever you want to do here. All right, you can solve for x, you can solve for y. Doesn't really matter. You're going to come up with the same answer. Now, I'm going to solve for x. I'm just going to pick x because that's what we'll deal with today. I could have used y, and like I said, we come up with the same answer. But I'm going to solve for x. So I'm going to take and I'm going to minus y from both sides. So now my new equation is going to be x equals 3 minus y. That's my new equation now. And that way I can take this value and I can plug it in to that equation. Okay, so x equals 3 minus y. I'm going to plug into the second equation. Alright, so let's get started. 2 times the x value, which is we found to be 3 minus y, plus 4y equals 8. Alright, now I chose to solve for x, and so all the terms in this new equation are in terms of y. Your first step, if you chose to solve for y, all your values would be in terms of x. So that would be the difference. You're solving for different variables in the beginning. Again, you're going to come up with the same answer. It doesn't really matter. Alright, let's distribute the 2 inside. So we're going to have 2 times 3, which is 6. 2 times the negative y, which is negative 2y, plus 4y equals 8. I'm going to combine my terms, my like terms here, and I'm going to move this 6 to the other side. I can either just move it and know that it changes the sign, or I can subtract it and it's the same thing. Doesn't matter. My combined terms over here are going to equal 2y. Negative 2y and 4y will equal 2y. 8 minus 6 is going to equal 2. I'm going to divide by 2, and y is going to equal a positive 1. Now, I've got 2 original equations up here that if I plugged in this 1, I'd have to do some moving around. So here's a little tip. When you're plugging your values back in after you've found a value of one of your variables, plug it into your isolated equation, and it'll give you a more direct answer without having to do as much work. So I'm going to take this 1, I'm going to plug it into that equation right there. It's the same thing. So I'm going to have x equals, which is nice, that's what I want. I want to know what x equals. So x equals 3 minus y, which we found to be a 1. So simply y equals 2. 3 minus 1 will be 2. And that is my solution to this system of equations. 2, 1. And I could plug those in, and you'll see right off the bat, we know it works in the first one, because 2 plus 1 does equal 3. But then 2 times 2 is 4, plus 4 times 1, which is 4. So 4 plus 4 equals 8. So it checks out in both equations, and we find that is our solution to the system. Alright, number 11 I'm going to skip. It's a lot like number 10. You have both equations with fractions in them. It's going to work out very similar to number 10. Number 12, let's look at number 12, because it also is another one we can address, maybe a few tips that can help us out as we try to solve for or determine which variable to solve for initially. If you'll notice, all of your variables have coefficients greater than 1, except for one of those. And which one is it? It's the y. In the second equation, there's a y that doesn't have a coefficient that's greater than 1. Now, why is that important? Well, whenever you begin to solve for one of your variables, and you're isolating it by itself, and you're putting everything on the other side, and then you're trying to get that variable by itself. Once you get it by, isolated on here, I'm going to have to divide by 4 to find out what this x is. I'm going to divide by 3 to find out what that x is. I would have to divide by 2 to find out what that y is. And that's going to create fractions on the other side in many cases. So to avoid having fractions in your expression that you're going to substitute in, try to pick a variable that doesn't have a coefficient, or at least a coefficient greater than 1. All right, so let's pick this right here. I'm gonna pick this variable right there to solve for initially. Okay, so let's do that. If I'm going to solve for this variable, I'm going to subtract 4x from both sides. So negative y is going to equal 4 minus 4x. And now, yes, it does have a negative 1 out there, and we have to divide by negative 1, but that doesn't create fraction problems for us in our expression. So we'll divide by negative 1, divide by negative 1, divide by negative 1. This is going to become positive. This becomes negative, and that one becomes positive. So I'm going to rearrange it. That's actually going to be a positive 4x minus 4, right? Because when I change the sign there, that becomes a negative 4. Change the sign there, it becomes a positive 4x. So this is my new expression for y. And notice, because it didn't have a coefficient greater than 1, I don't have any fractions to deal with when I plug in or substitute in my expression. So now let's do that. I'm going to take this, plug it in to y right there. Okay? So the first equation is going to be 3x minus 2 times 4x minus 4 equals 3. Okay, so now I have to do some distribution, and we talked about it earlier, and we are seeing it again now. We've got a negative 2. Carry the sign with it as you distribute into your parentheses, and you won't have to worry about sign problems later. So you're going to have 3x. Negative 2 times 4 is a negative 8x. Negative 2 times negative 4 is a positive 8 equals 3. Well, we're going to take this 8 over here. Remember, if we move it across, it just changes the sign, right? So that 8 is gone. And then we're going to combine these two x terms together. 3x minus 8x is going to equal negative 5x. 3 minus 8 is going to be equal to negative 5. Divide by your negative 5. Divide by your negative 5. X is going to equal a positive 1. And again, remember what we said earlier, that if we can get our isolated equation and plug into that equation, it'll immediately have y by itself. So let's do that. Y is going to equal 4 times 1 minus 4. And 4 times 1 is 4, and 4 minus 4 is simply 0. So we have both of our values here. X is going to be a 1, y is going to be 0, and that is the solution to this system of equations. Oh, wow. Someone was very excited to be here. They let out a great big yawn. All right, so let's look at a problem on the back page. So let's flip the page over. And let's look at a couple examples there. Number 16, 17, or 18. Let's look at number 17. Looking at number 17. All right, so on number 17, we've got a couple of options, but both of the options that we have are for the same variable. Which variable on 17 should we solve for? If we're trying to use our tips in finding a variable that doesn't have coefficient greater than 1, which variables are we going to look at solving for? Y. Y doesn't have a coefficient that's greater than 1. So when we are trying to solve for either one of these y's, we're going to end up with whole numbers instead of fractions. So let's solve for the top one. The top one's going to be pretty easy. We're just going to take and add 5x to both sides. Right? So our new equation will be y equals, I'm going to rearrange this and put the negative at the end, so 5x minus 2. That's going to be my new equation solving for y in this equation. And so now I've got this expression that I can take and I can plug that in to the other equation. All right, let's do that. So we're going to have negative 4x plus y. Well, y is going to be 5x. And because this is positive, I'm not going to worry about putting the parentheses because it doesn't do anything for the signs. And that's going to equal 2. Okay, so then I'm going to move this 2 across or add it to both sides. So we'll add 2 to both sides. And I'm going to combine these terms over here. Negative 4x and positive 5x is just simply x. 2 plus 2 is 4. And I'm going to take that and plug it into the simplified or the isolated variable equation right there. I'm going to solve for y. Y is going to equal 5 times 4 minus 2. And 5 times 4 is 20. Minus 2 is going to equal 18. So y is going to equal 18. Now let's check those. Let's check those. If I have 4 times, or negative 4 times 4, I have a negative 16. Y is 18 positive, and 18 minus 16 is a positive 2, so that checks out. And we know it works for the top equation because that's the one we use to find the variable value itself. So our solution to this system of equations should be 4 comma 18. That is the ordered pair and the answer to number 17. All right, let's work at the word problem, and we'll be done with our examples for the notes. We will have practice that we'll work on tomorrow, the practice paper, and I will probably have a video working a few examples on the practice as well. So if you're looking for that, that should be online as well tomorrow. All right, number 19, an adult ticket to a museum costs $3 more than a child's ticket. When 200 adult tickets and 100 children's tickets are sold, the total revenue is $2,100. What is the cost of a child's ticket or the children's ticket? This one's not too difficult to work, and I am going to help maybe simplify things a little bit. Let's look at the child's ticket, and let's make it our X variable. And then the adult ticket will make Y. And I'm just doing that so that we see X and Y and we can be comfortable and familiar with a variable that we're used to seeing. We could use C and A, and that would be fine. But just so that we've got X and Y, we're just going to use that. And it tells us that an adult ticket, Y, cost or is equal to $3 more than a child's ticket. So if I had X plus 3, that's what Y should equal, right, when it's dealing with the cost itself. All right, now when I'm dealing with the number of tickets that are being sold and the total revenue, well, 200 times the adult tickets, so 200Y, plus 100 times the child's tickets should equal $2,100. Now we've already got a variable alone, isolated, and have an expression for this variable, so I can take this right there and plug it in to the other equation where I see the X. Or, I'm sorry, where I see the Y, not the X. Disregard that. Where I see the Y. So I'm going to do that. I'm going to plug in 200 times X plus 3. 200 times X plus 3. Alright? And then I'm going to add to that 100X. And that's supposed to equal 2,100. So I'm going to distribute my 200. I'm going to end up with 200X plus 600 plus 100X equals 2,100. A lot of zeros, a lot of hundreds going on there. That's okay. All right, I'm going to subtract 600 from both sides. That'll go away. I'm going to combine my 200 and 100, which is going to equal 300X. And this is going to equal 1,500 on this side. I'll divide by 300. Divide by 300. And that'll cancel, and X is going to equal 5. Well, that's actually all we really need to know, but let's go ahead and solve for Y so we have our solution to this set as well. If X is 5, I'm going to plug this in to that equation and find out what Y equals. Well, Y is going to equal 5 plus 3, so Y is going to equal $8. Now, the answer that it was looking for was this right here. This is the cost of a child ticket. $5. And that's the answer to number 19. By using substitution, we can solve those two equations that they give us. All right, hopefully this has been a help to you on the notes, and we will work on practice video tomorrow and work on your practice in class tomorrow.